All right, hello students. Today we're going to move on with the next lesson. We're going to go ahead and talk about, lesson 9, tables of equivalent fractions. So we discussed equivalent fractions. Now we're going to create a table using equivalent fractions. All right, so let's go over example 1. To make paper mache, an art teacher mixes water and flour. For every 2 cups of water she mixes, there's 3 cups of flour, so that's a ratio. So let's go ahead and underline that. 2 cups of water. Um, 3 cups of flour to make the paste. So we need paste to do the paper mache. All right, so here it says find the equivalent ratios for the ratio relationship. 2 cups represent the equivalent ratios in the table below. All right, so here we have cups of water, cups of flour. So let's go ahead and grab our pen and let's go ahead and start filling it in. Well, first we start with the ratio presented or ratio given. So here we have 2 cups of water, 3 cups of flour. So we're going to start kind of with the simplified ratio or the ratio given that's presented right here. All right, well, to make equivalent ratios, these numbers have to get bigger or smaller. So let's go ahead and increase them. Well, here in the water, well, if we increase it by 2, or multiply this by 2, we increase this side, or the flour side, by 3, or multiply it by 2 again. So there we go. So we can keep doing that all the way through. I add 2 to the water side, 3 to the flour side. So I get 2, add 2, I get 6, add 3, I get 9. Do it again, I add 2, I get 8. I add 3, I get 12. And let's go ahead and do it one more time to complete the table. Add 2 over here to this side, I get 10. And add 3 over here, I get 15. All right, so here's a list of equivalent ratios. These are all equivalent to each other because we kept the addition consistent on each side, adding 2 to the left side, adding 3 to the right side. We could also talk about multiplication. If I multiply 2 times 2 is 4, 3 times 2 is 6. And we can do it again. 2 times 3 is 6, 3 times 3 is 9. And we can keep doing that all the way down. All right, so that's kind of what we're going to be doing today. We're going to do one more video with some other examples. All right, hello students. Now we're going to move on with exercise number 1. So let's go ahead and kind of look at the problem. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table and answer the following questions. So we should identify the ratio that is given. If we look up here, 2 cups of cornmeal for every 9 gallons of water. So we should identify that we have a 2 to 9 ratio. So that would be our first box. So we just simply identify the ratio, and then of course we plug it into the top. Now for the cups of cornmeal, now let's complete this table down here. Now for the cups of cornmeal, we're going to add 2 each time because that's the number given here. And for the gallons of water, we're going to add 9 each time. So let's just simply go through the addition. 2 plus 2 is 4. 9 plus 9, is 18. Keep going. 4 plus 2 is 6. 18 plus 9 is 27. Continue to go. 6 plus 2 is 8. 27 plus 9 is 36. And of course, the last one, go ahead and add it. We should get 10 and 45. All right, so we completed the ratio table. Now from this information or from this table, we should be able to answer the following questions. All right, so let's go look at A. How many cups of cornmeal should be added to 45 gallons of water? Well, to keep the ratio consistent, or to keep the ratio the same, first we need to identify what we're given. Well, we're given this information, the 45 gallons of water. Well, we go to the water side, and we see that here's the 45 gallons of water. What coincides or what works with the 45 gallons in cornmeal? Well, this is the 10 right here. So we need 10 cups of cornmeal for the 45 gallons of water. So let's go ahead and kind of type in our answer or talk about our answer. Remember, we want to answer the question fully. So to say that we have 10, or we need 10 cups of cornmeal should do 45 gallons. I identified kind of the answer of 10 cups of cornmeal and identified kind of what they're referring to in the questions. So please make sure all answers are written out appropriately. The work's already done up here, so we don't have any work to show. The work is from the table itself. So let's go ahead and look at letter B now. Paul has only 4 cups of cornmeal. How many gallons of water should be added if he wants to make as much cornmeal juice as he can? So once again, identify the information provided. Here it says Paul has only 8 cups of cornmeal. Okay, and he wants to make, excuse me, he wants to know, we want to know how many gallons of water he needs. So let's go back to our table. And we have 8 cups of cornmeal. So we want to go to the cornmeal side. Let's kind of use the same color. And here is the 8 cups of cornmeal. How many gallons of water do we need? Well, we need this 36 right here. We need 36 gallons of water. We need 36 gallons of water. So let's go ahead and type out an answer. So what would Paul need? Paul, or what should he add? Paul should add 36 gallons of water. There you go. There would be the answer. All right, let's go ahead and go over the last one as well. Letter C. What can we say about the value of a ratio in the table? Well, remember, here we go again. The value of a ratio. This is the kind of the third time we've discussed the value of the ratios. Excuse me, plural. So, what can we identify about the value? Of all these ratios. Well, we took the time and we wrote them all as fractions and then simplified it. Let's kind of just look at one of them. If I wrote the first one as a fraction and simplified, well, the first one's already simplified. If I took the second one and did the same thing and actually simplified it down, so remember I could divide this both top and bottom by 2, and I simplify it down to 2 over 9, we should notice that these values right here are exactly the same. Well, since we developed all these ratios from this beginning one, we should notice that all of these are equivalent. All of them have the same value of the ratio. So that's what it's asking. What should we notice, or what can we say about them? We can say that the value of each of the ratios are equivalent. It should be the value of the ratios are equivalent. We know that because we could do the division of all of them. If we developed them all from the beginning one, they all have to be equivalent. All right, so you should be able to move on to your assignment for today. So go ahead and turn off your computer.